Hi, welcome back to AT Math. Today, 10-7, independent and dependent events. Basically, if you remember from before, an independent event is something you choose, and the dependent event is something that's caused based on your choice. Take a look below. They have a picture here of a boy reading books. And if he were to able to choose one book from each list, notice how they're all different books in each list. So whether he picks Animal Farm in this book and Wuthering Heights in this book, that's fine. One choice does not affect the other. But in this one, if they're the same list, if he chooses Animal Farm here, well, he can't choose it again over here, so he only has 4 possible choices to choose from if he's just looking at one list. So in this case, choosing 2 books or 1 book from each list is independent. It doesn't matter which one you pick. And this one it does, because by choosing Animal Farm, you now have one less choice from that same list. Events are independent if one occurrence does not affect the other. Events that are dependent if one event affects the other. Now, a dime lands heads up and a nickel lands heads up. The result of tossing a dime does not affect the tossing of a nickel, so they're independent. Just because I flip a dime one way doesn't mean a nickel is going to work the same way. However, if you choose a colored game piece in a board game and then your sister picks another color, or let me give you an example. Suppose Monopoly. Suppose you pick the car. That's always my favorite, is picking the car. Well, if I pick the car, that means you can't. You might have to pick the battleship or the dog or the shoe, or here they come up with new ones. The point is that as someone takes something and you can no longer pick that, that changes what you can actually pick. So that's dependent. So take a look here. For instance, if you were to suppose an experiment involving flipping 2 fair coins. The sample space of outcomes shown in the tree diagram determine the theoretical probability of both coins landing up. In other words, if you say heads or tails, and you flip, it can either be heads or tails. Another coin you flip could be heads or tails. So basically, if you remember from a couple sections ago, the chance of getting both coins either heads up or both tails or a certain way of each, well, if you want both heads, it's going to be 1 out of 4. Both tails will be 1 out of 4, and so on. If A and B are independent events, then P times A and B equal P times A and P times B. We'll show you here. An experiment consists of randomly selecting a marble from a bag, replacing it, and then selecting another marble. If the bag contains 7 blue marbles and 3 yellow marbles, what's the probability of selecting a yellow marble and then a blue marble? Let's first go ahead and write down what are the different amounts. 7 blue, 3 yellow. They want me to the chance of me landing a yellow marble. Well, there's 3 yellow marbles, and probability means part versus total. There's 10 total marbles. Therefore, you have a 3 out of 10 chance. Then, if you want to then land a blue marble, there are 7 blue marbles out of a total of 10. Therefore, the probability of landing yellow then blue is going to be 3/10 times 7/10, and when you run the numbers, it's 21 out of 100, or basically just a little more than 1/5 of the percent. 21% basically. If it mattered, if it was yellow than blue. When a person rolls 2 dice and they land showing the same number, we say the person rolls doubles. What's the probability of rolling 3 doubles in a row? And again, if you've ever played Monopoly, you know that if you throw 3 doubles in a row, you go directly to jail. So basically, the result of one roll does not affect any rolls. The events are independent. So we can basically just compare and see what are the chances of rolling a double. Here are all 36 possible rolls of a dice. 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, etc. Notice here that these guys are the doubles. All you have to do is say, well, how many possibility of doubles are there out of the total? Looks like there's 6 possible doubles out of 36 possible combinations, which means you have a 1 in 6 chance. The chance of doing that 3 times in a row then would be 1/6 times 1/6 times 1/6, which would be 1 over 216. Trust me, I'm a math teacher. Therefore, yes, 1 in 216 chance of rolling 3 doubles in a row. And then as for an experiment consists of spinning the spinner twice, what's the probability of spinning 2 odd numbers? Here, there are 3 odd numbers of a total of 6, so 3 over 6 which makes 1/2. To do that twice, 1/2 times 1/2, the probability of landing 2 odd numbers in a row are 1/4. Suppose an experiment involves drawing marbles from a bag. Determine the theoretical probability of drawing a blue marble and then drawing a second blue marble without replacing it. So for the first draw, take a look at the blue. We have 1, 2, 3, 4, 5, 6 out of 9. So the first time I have a 6 out of 9 chance of getting a blue dot or a blue marble. That would be 2/3, by the way. However, if I took a blue one away, that's now missing. The chance of me getting the second one, let's see, determine the drawing a blue without placing the first one. So the second one, I'm only going to have 5 marbles instead of 6. So you'd only have, basically you should have taken a blue one out, you should have 5 out of 8. And to find the probability, you would times them up and you would say you have a 30 out of 72. Now in this case, what they're doing in the example though is they said, okay, we're going to go the other way though. They're deciding not to take out a blue marble. They actually picked a red one. So right away, by taking a red one, you've taken away the red here. You still have 6 blues to choose from, but now there's only 8 marbles total. Therefore, your chance of getting a blue marble now in the second draw is 3 out of 4. Why did it go up? Because you removed one of the unlikely or one of the negative possibilities. You had 3 chances not to get a blue marble, and you took one away. So now there's only 2 chances not to get a blue marble, and 6 are still going to be a blue marble. And that's what you got to do. So probability of drawing a red marble in the first draw based on this versus the second one. And there you go. So now they kind of switched up on you here. They went blue this time, but if they went red, let's go red now. Okay. Well, red the first time you have 3 out of 9, which is 1/3. And this time by taking a red guy out, you have 2 out of 8, which is 1/4. So basically the chance of getting 2 reds in a row is 1/12 if you times them together, because 1/3 and 1/4. To determine the probability of 2 dependent events, multiply the probability of the first event of the probability times the second, which we just did. So there are 7 pink flowers and 5 yellow flowers in a bunch. Jane selects a flower at random, and then Leah selects a flower at random from the remaining flowers. What's the probability that Jane selects pink flower and Leah selects a yellow flower? Well, let's first run the probability. There were 7 pink flowers, 5 yellow flowers. Therefore, there's 12 total. And Leah picks first, and the chance of her picking a pink flower, since there's 7, is 7 out of 12. However, by taking that pink flower out, now there's only 6 pink flowers. Okay? Now, the chance of Leah selecting a yellow now, there's still 5 yellows to be had, but now there's not 12 possibles anymore, there's only 11. Therefore, 7 12s times 5, 11. 7 times 5 is 35. And 12 times 11, I believe, is 132. Therefore, that's your probability, which would roughly be about, I want to say about 1/3, give or take. And I'll save you all this writing here. 35 over 132. And that's it. We're done. Again, we'll do some more of this in class tomorrow. Thanks again. Bye.